So an activity you're going to be doing soon will be trying to predict Old Faithful's next eruption. So you remember from class when you watched Old Flaskful going off, and you can see from the video right here that as this thing is going, it's generating lots of heat. Finally, it flashes into steam, and then the water comes shooting up the tube and out the top. So there's an awful lot of pressure built up in there. There's an awful lot of things going on. So taking a look at this, you can see that we actually have what we call a plumbing system. We have the flask at the bottom, and what we can't see underneath is the heat that's down here, but there's a heat source. And so in order to keep all the water contained, it has to be in some sort of a system. So again, we have the flask down here at the bottom, and then as the eruption goes on, as we watch this video, you can see that the next part of that is the piece of glass tubing that the water goes up, and then at the very top there's a funnel that allows the water to come out at the top. So all of those together form a plumbing system, and real geysers have a plumbing system as well, as you can see from this diagram right here. And so again, here's a heat source. There's a way for the water to work its way up through the ground. There's a series of cracks and channels and crevices that have been created over time, and the water just works its way up through there. And sometimes there's a place where the water kind of gathers because there's a constricted spot. There's a place where the rock kind of forms a really small opening like that. So the water builds up down here, then it has to force its way through that. So as that superheated water gets to spots like that, it kind of builds up behind there until it flashes into steam. Eventually, it'll make its way all the way out the top and come out as a geyser eruption. Here's another example of that over here in this diagram, but you can see in this diagram how there are layers in the rock, probably a little bit more true to life than this one, because there's varying layers of rock underneath the ground, and the water's having to find its way up through all of those different crevices and cracks in the rock. This particular diagram actually shows all four features of excuse me, of the hot springs. There's a hot spring pool, here's a geyser right here, there's a mud pot, and finally there's a fumarole, which is just a steam vent over there. So one of the things we know about geysers is that there's a period of time when they go off, and then there's a period of time when they're sitting here and not doing anything, that time between the eruptions. And these geysers in the back are just steaming a little bit, they're not doing anything. So if you're just hanging out, oftentimes when you're just walking through Yellowstone Park, you're often there when they're not going off. So what do we have then is this series of eruptions, wait time, and then another eruptions. So what we were able to do is to actually name these. When the eruption is actually happening, we call that the duration. So that's supposed to be a letter D. The time between between two durations, I'll put another D over here for another second duration. The time between those durations is called the interval. It's the time between. So we are now left with a question, whether or not there's a relationship between the duration when a geyser is going off and the interval. And if there is a relationship, can we use that information to predict a future eruption? So fortunately for us, when it comes to Old Faithful geyser, for example, we actually have the information, because people have gone in, and every time that eruption takes place, they will mark the duration, how long it lasts, the interval between the eruptions, and then using that information, somehow they're able to, at times, maybe predict when a geyser will go off. So you're going to need a graphing calculator, and hopefully you remember how to set up a simple data table with an X and a Y. And you're going to get a piece of paper that has actual Old Faithful eruption data on it, and you can see that there has a duration. It's listed in seconds, and it has the interval, which is listed in minutes. And one of those columns of data will be your x-axis, the other column of data will be your y-axis, and then you'll plot those, put all that information into the graphing calculator, and then create a scatter plot. And then take a look at that scatter plot and may have to get together with a few of your classmates and see if you can begin to interpret that data to answer the question whether or not there is a relationship between the duration and the interval of a geyser, and then can you use that information to predict a future eruption.